Okay, hello everyone. This is Maurizio, editor of Power Electronics News and eWeb. Today we are with two great speakers, Robert Misback and Adam Kabulski, both at Mitsubishi Electric. Robert is Chief Operating Officer and Adam is Vice President with Mitsubishi Electric Power Products. Hi, Robert. Hi, Adam. How are you?
Doing well, Maurizio. Thanks for having us.
Yes, good morning, Maurizio.
So thanks a lot, Robert and Adam, for having you here to talk about smart energy for the future of the planet. This is a great topic, I guess. But before starting, please introduce yourself, Robert and Adam.
Okay. My name is Bob Misback. As Maurizio said, I'm Chief Operating Officer of Mitsubishi Electric Power Products. We're a wholly owned subsidiary of Mitsubishi Electric Corporation, and we take care of infrastructure industries for Mitsubishi Electric. And our biggest infrastructure industry that we work in is the electric power industry. And I've been in the electric power business really my whole career. I began in power generation business, traditional power generation, then moved into renewables and battery energy storage. And now in Mitsubishi Electric, we work with all those different technologies. Predominantly, our biggest part of our business is in transmission and distribution.
Excellent. Adam.
Good morning. So Adam Kabulski, I'm the Vice President of Sales for Renewables. So I joined Mitsubishi Electric in 2017, primarily to launch sales into the solar industry, and then following that into energy storage. So grid scale energy storage solutions. And power electronics are near and dear to me. I actually started my career as an engineer designing low voltage drives, so variable frequency drives, which then were used to build some of the early 1,000 and 1,500 volt solar inverters. So I spent a lot of time as an engineer working with power electronics, and now I'm selling them.
Excellent. Okay, so I would like to talk with you about smart energy, renewables energy, and so how we can see the future of the planet. So zero emissions is a target of many countries that are willing to reach by next year, by 2050. And we can see a lot of investment in terms of grid technology, energy storage, etc. Renewables, power grids, and other energy trends emphasize the reliability of aging electrical infrastructure and transmission, but also distribution lines around our world. Growing and supporting renewable energy pose a lot of challenges, as you know. How do you see the future of renewable energy adoption? I guess that we must increase even more solar, wind, these sources, renewable energies for reaching for the zero emission goal. What do you think? Robert, you can start.
Yeah, I think renewable energy has a tremendous amount of momentum in the United States right now. I think the last quarter, we set another record for renewable power deployment. And I think a lot of states are reaching their renewable power goals even earlier than they had originally planned. So that shows that renewable power generation technologies are already becoming the most economic alternatives in many markets. And that really, that economic advantage is driving their adoption more than state mandates in many cases. So that's kind of the first point, is that there's already a lot of momentum. And I think we're starting to see the beginning of sort of a self-reinforcing cycle of adoption of renewable power. Mm-hmm. Because since wind and solar power don't have any fuel cost, in the markets where they're being adopted, you're seeing lower and lower prices for energy. right? And that is in turn driving more demand, and it's also starting to drive electrification of more industries, which is going to increase the demand for electricity, right? So then you're getting into this self-reinforcing cycle. It's kind of the same thing that happened in the communications industry when smartphones came out, and the price of data transmission started to go down further and further, which led to more and more applications for smartphones. So I think that's all positive. But as you say, it's hard to know if our current set of market conditions is going to lead us to zero emissions soon enough, right? And I think transmission and distribution capacity could likely become a limiting factor, right, in renewables deployment. Already, our studies group is seeing interconnection queues in most of the country are stacked up with interconnection requests from renewable power and energy storage projects. And so those studies are really uncovering the need for more transmission and distribution capacity. So I think this is going to play out over years, right? That the upgrading of the electric grid is going to be a multi-decade exercise. So I think new technology is gonna be necessary to speed this thing up. So
Thanks.
those are
Adam.
that's key points that I think.
Thank you, Robert. So Adam, what do you think?
Yeah, so the US is unique in that we are driven by individual states, each with their own policy. So in the earliest days, this was policy driven. And even today, it still is to some degree. But I think currently we have maybe 17 states, and I believe also District of Columbia and Puerto Rico have 100% clean energy commitments. And if we look at states that have some commitment down to 25%, that increases to maybe, I think, 37, 38. So we have just so many states in the US that have made this commitment. And even the ones that haven't, that's primarily the southeastern US. So yes, they don't have clean energy commitments, but they have great solar resources, and just pure economics are driving growth. I mean, look at what's going on in Florida, millions of commitment of 1 million panels of solar. Tennessee, TVA has committed gigawatts of renewables. So whether it's policy or the economics, we're just really seeing strong commitments to 100% energy goals. And that in turn is going to increase renewable energy adoption. And I think those percentages and those numbers are going to further increase as the early leaders prove it out. So as they show the economics do work, as they show that the technology works and that the integration challenges aren't nearly as bad as people think, you're going to see just massive adoption across the entire US. I mean, talking about the aging transmission, like it's really going to get highlighted though, because here in the US, we have great wind resources in the middle part of the country, great solar resources in the southern half, but that's not where our load pockets are. Our load pockets are on the coasts, and especially in the Northeast. So the people that are needing that energy are very far away. So we're testing that transmission infrastructure, and we're showing that it really needs to be upgraded and improved. And I think this is an opportunity for us, as a provider of high voltage DC transmission, this is where DC transmission will really shine. So bringing, large generation resources all the way across the country, and then even offshore. We're starting to see the early days of offshore wind. We've got these good resources in the Northeast, but you got to get it somewhere, and there's no transmission infrastructure right now.
Excellent. So I mentioned at the start several technology, energy storage, but also grid technology, smart grid. So we have a lot around smart grid. The grid of the future is all about renewable penetration and increasing the electricity consumption. So power grid technology, of course, can improve energy efficiency. So how is renewable energy impacting the power grid? So I guess that we also should look in terms from a perspective, a good control definition, optimization, digital management of distributed energy resources. So should we talk about any standards also too? Robert.
Of course, I think information technology is key to modernizing the grid, right? You need technologies which are able to understand what the situation of the grid is and diagnose where electricity needs to flow and how to control the flow of it. And so to do that effectively, right, you need standard communications protocols so that all the grid's devices can communicate with each other. So that's a big area, I think, of standardization. And I think increasingly you want the grid to be sort of a plug and play environment, right, where you can buy a device, plug it into the grid, and it becomes part of the network and is able to communicate and act in concert with other parts of the network. The other place that I see standardization or rules kind of helping is especially in the solar industry, you know, the amount of capability that's in each inverter and the technical capabilities of each generation, whether it's wind or solar, each generation plant has to be modeled and understood, you know, to figure out what the effect of the effect on the grid is. So those are two areas where I see increasing standardization and standard creation of standards.
Thanks. Adam.
So the cybersecurity concerns are valid. It's something that's no more apparent than really right now in the US following the Colonial Pipeline incident. So that's everyone's worst fear. Can you cripple the infrastructure through a cyber attack? And it's something to be rightfully concerned about. But I always like to stop and think first, do we live in a connected world or an unconnected world? And it's clear over the past decade, the world is more connected than ever. The benefits of data is clear. So let's accept that there are so many benefits to being connected digitally and build the standards, build the systems in the safest way possible. And here in the US, we have great standards through NERC, right? NERC has its critical infrastructure program, well-defined cybersecurity requirements. We followed those on projects and it works well, but you have to embrace the risk that occurs. You have to embrace what could go wrong and build a very robust system, protect everything, put the right hardware and software, and even just programmatic and people concerns, like make sure that you're protecting everything from not just the intrusive attack, but the accidental fault through human error, and build your system so that it's robust. But I just see too many benefits to being fully connected, taking advantage of the data and optimizing the system to say that we shouldn't be thinking cybersecurity. We should just be disconnected and live in a 100-year-old grid like it used to be.
So power grids involve several technologies. What is the most critical? So which one can be a good boost for the success of grids? Robert.
So I think the key capabilities for the future are controlling the flow and quality of electricity and storing that electricity. Okay, and so to get those capabilities, two technologies that we have put a priority on are number one, power electronics. So power electronics technology enables you to control the flow and quality of the electricity, which has never really been possible. I mean, electricity follows the path of least resistance. So you've never been able to control the flow of electricity really as well as you can now with power electronics. And power electronics enables you to transform DC current into AC current, which is an enabling technology for most renewable power, including wind and solar power. And any kind of a battery usually involves DC electricity, right? So then power electronics is basically an enabling technology for all three of those applications. And then in transmission, as Adam mentioned, we're doing high voltage direct current transmission lines, right, which is another key component in the modern grid to be able to transport large quantities of power. So power technology or power electronics, I think, is a key thing. The other one, as I started to mention before, is information technology, right? Because in order to control all these devices in the most efficient way, right, you have to be able to monitor the grid, realize the situations, forecast what's going to happen in the coming minutes and seconds, and then tell all these devices that are installed in the grid what to do in order to keep the grid efficient and stable, right? So those are the two technologies that we think are going to be important in the future: power electronics and information technology. And information technology also will help you reduce the operation and maintenance expenses, right, for the grid. So so those are the ones that we've put a priority on.
Excellent. So Adam, for you, which one can be a good boost for the success of grids?
Yes, I'll just build on the power electronics answer. I mean, that flexibility is so important to the grid. And again, it's things like PV inverters, energy storage. And let's look at how well those systems performed during the winter storm, the February storm that kind of wreaked havoc on ERCOT. So all of the challenges related, or most of the challenges, I should say, were related to rotating machinery. You know, either whether it was the fuels getting delivered to traditional generation or the rotating portions of wind turbines. But power electronics, we've always designed them with hot and cold extremes in mind. They're static devices. There's no moving parts. They work well in these demanding climates. And that's not even taking the performance benefits into account. Power electronics inverters have sub-second response times, highly fast ramp rates. They can supply reactive power. They can inject harmonics to provide harmonic mitigation. They can do all of these things that just traditional generation was never able to do. So the grid is able to perform in a way that the early inventors of the electric grid just didn't envision. So more power electronics is going to be a great thing. They're reliable, they're functional, they're flexible. I think that's going to be just a core component of the power grid in the future. And then the other storage, and we'll get into more detail on it, I suspect, but whether it's short duration, on the order of hours, or long duration, 12 hours, 24 hours, or even seasonal storage, this is going to be the most critical technology that's possible, because that's what's going to allow us to retire gas generation. That's going to be able to retire nuclear generation. It's going to allow us to make renewables look more like firm capacity.
So energy storage, battery energy storage is another trend that can support, in this case, the request of high peaks of current, but also the advent of electric vehicles. So renewable energy for use later, and energy storage on the grid for various goals, for various targets. So what parameter should designers consider concerning energy storage? What are the challenges? What is the future of energy storage? Robert.
So I think energy storage, we can see that energy storage, when energy storage first came out, everybody thought it was too expensive, okay? Yep. But now I think it's clear that energy storage is starting to make electricity cheaper and cleaner. Okay, so the first place energy storage was economic in the United States was in the PJM and some of the northeastern markets for frequency regulation, right? Which is stabilizing the grid from short-term ups and downs in supply and demand, right? And to do that, you need a battery with a duration of about 15 minutes. Right, so the first batteries that were economic in the grid in the United States were 15-minute batteries, and then over the past couple of years, you've seen the demand for energy storage in Texas take off, right? And most of those systems are 1-hour batteries. And also recently, we've seen some big systems put up in California to cover the peak shifting, to cover the late afternoon, early evening peak when the sun is going down and the solar power is dropping off.
Yeah.
And those batteries are 4-hour batteries in most cases, right? So you're starting to see energy storage be adopted for these short-term applications. The cost of frequency regulation in PJM, I think, is less than half of what it used to be before energy storage, right? So that cost gets folded into the price of electricity. So energy storage has really reduced the price of electricity in PJM, and it's starting to have the same effect in other markets. So I think it's already, starting to show its value, not only in price, but in, all that short-term fluctuation used to be taken care of by ramping up and down fossil units, which had a lot of emissions, right? So it's already making, things cheaper and things cleaner. The challenge for energy storage is growing in application and duration, right? In other words, we're starting to see people experiment with hydrogen, for long-term energy storage, other types of technologies. And that's going to be, I think, the ongoing challenge in the coming years, is to address more, find more applications that energy storage can help in.
Adam, what do you
Yes,
think?
you touched on electric vehicles, and it's very interesting to me how closely coupled grid storage and electric vehicles are. They are one another's biggest ally and threat. So the real explosion of energy storage globally has been due to the cost decline. And that cost decline is purely based on customer adoption of electric vehicles. We're seeing globally just massive amounts of consumers that are buying electric vehicles. And that explosion in the supply chain is what gave us in the grid industry access to low-cost batteries. So on one extent, we are following their cost out, we're following their technology, and it's a good fit right now. But we're starting to see, and really 2020 showed it to us competing for resources now. So China puts a mandate for electric vehicles, and all of a sudden, the grid industry can't find batteries anywhere. And that was an eye-opening moment. And that had people start to look at what else is there? What types of chemistries are not dependent on electric vehicle supply chain? Can we go to compressed air again, or is hydrogen the future? So everyone had this real watershed moment of, we depended on electric vehicles, and all of a sudden they could take our entire supply chain away and leave us without any solution at all. But the other piece where they're tied together, and it's really interesting to me, is the EV itself is a distributed battery. We're soon going to have millions of batteries just driving around and really positioning themselves where we need them most during the day. They're going to be parked sitting idly at the load center, right, where people are going to work. So we have these assets that aren't being used for their intended purposes, but can we use them? Can we start using these batteries at customer facilities for peak shaping? And then when they drive home in the evening, can it be backup for that person's home? Can that become a backup solution? So this hasn't been solved well. There are some tests. Mitsubishi Motors has been involved in some tests, as well as Mitsubishi Electric in Europe. And we're learning this, and just the pure benefits of having these assets, moving where they're needed, and dual use, because the batteries are getting better and better. And they don't need to just be for a couple 100,000 miles of discharge. They could be used for, full depth daily cycling. And it's a really, really interesting challenge and opportunity.
Excellent. So we are in conclusion. Just the last one, just a look into the future, very fast, few words. How do you see the future of energy, Robert?
I see the future. I'm an optimist, so I really see this unfolding well. I mean, I see this whole thing driving down the cost of electricity in the long run, and driving up the uses of electricity, right, in the long run. So when I look out, 20, 30 years, I see, most industries have been electrified, and we're all using clean power, and the grid is stable, right? The supply is reliable, and the power quality is very good. So I do think there's a lot of momentum going in the right direction. I think it's a question of how fast can we get there.
Thanks. Adam.
The future of energy, it's cleaner, it's cheaper, and it's more flexible than it's ever been.
Excellent. Thank you, Robert. Thank you, Adam. Thanks for this great interview. It's been a pleasure to talk with you about smart energy for the future. Thanks a lot, Adam. Thanks a lot, Bob.
Thanks, Maurizio. Great to have us.
Thanks.
Stay tuned. Goodbye.
Goodbye.